Okay, briefly, if we fall from here to here, our displacement is from here to here. Now this diagram's cluttered up from what it was before, so you can look back at the previous video what it looked like before I cluttered it up. But here's our displacement, so here's our displacement vector, here's our gravitational force vector. To find the work, we have to project the gravitational force vector onto the delta S vector in order to get the projection, which is the component of gravitational force in the direction of motion, and that's what we multiply by our displacement in order to get the work done by the net force, and the net force is the gravitational force if we assume no friction and everything. Okay, so that's very easy, and that ultimately comes out, we multiply the projection of the gravitational force of delta S by delta S, the scalar projection by delta S, which means we're multiplying the component of gravity in the direction of delta S by delta S, and we can take that as F grav parallel times delta S. Very easy to calculate as long as you know the magnitude of the projection and the magnitude of delta S, but we don't know either one. How do we find them? Well, all we need, we know what the gravitational force is, it's 2 newtons. Okay, all we need is this angle, and we can get this projection from the cosine. How do we get this angle? Well, in our picture, we have a 45-degree angle from here to here. We observe that the triangle from here to here to here and down is an isosceles triangle, so that this altitude cuts it in half. Well, using that with what's known, it's easy to find this angle, so figure that out. I said a little more about it in the full video, but this is the brief one. Okay, and then how do we get delta S? Well, we have this triangle here. This is our 40-centimeter length of the rod, and this angle's 45 degrees, so we can find this side, and we can find this side of this triangle. Having found those 2 sides, it's a fairly short step to knowing what the 2 sides of this right triangle are. This right triangle having delta S as its hypotenuse, and you can use the Pythagorean theorem. Once you know those 2 sides, you can find the magnitude of delta S. So that from this angle you can find F grav parallel, and then you can find the magnitude of delta S from this triangle.